Good morning, Course 2 people. Here we are on Lesson 100, Estimating Square Roots and Irrational Numbers. You should be on page 693, and I'm going to go over the new concept before I explain all the examples. These counting numbers are perfect squares: 1, 4, 9, 16, 25, 36, 49, 64. Recall that a square root of a perfect square is an integer. So the square root of 25 equals 5. The square root of 36 equals 6. The square root of a number that is between two perfect squares is not an integer but can be estimated. So when we look at a problem like the square root of 29, we know right away that's not going to be an easy number. Since 29 is between the perfect square of 25 and 36, we can conclude that the square root of 29 is somewhere in between the square root of 25 and the square root of 36. So looking at that last line in your book, square root of 25 equals 5. The square root of 29, we have a question mark. And the square root of 36 equals 6. Turn your page. We see that the square root of 29 is between the number 5 and 6. On this number line, we see that the square root of 29 is between 5 and 6, but it's not exactly between the two. So here's example 1. Between which two consecutive numbers, whole numbers, is the square root of 200? Well, and we think about it, the square root of 100 equals 10. And so the square root of 200 is going to be larger than 10. So we might guess that the square root of 200 is 20, but if you check it, you'd say, okay, 20 times 20 is going to be 400. That's way too big. That's not the number. So now we have to guess somewhere between 10 and 20, and your book has you guess 15. So 15 times 15 is going to equal 225. Well, that's still too large. It's larger than 200. So now if we go to, okay, so it's not 15, let's try 14. So 14 times 14 is equal to 196. Well, this one was too big. This one was too big. And 14 times 14 is now too small. So now we know we're somewhere between 14 and 15. We have narrowed it down. So the square root of 29 is going to be somewhere between the whole number 14 and the whole number 15. At the beginning of this lesson, you found out that square root of 29 is between 5 and 6. You can refine our estimate by finding a decimal, and they give us some examples here of 5.4 times 5.4 would give us 29.6. 0.16, that is too large. It was over 29, that much over 29. So then we try 5.3 times 5.3, and that's 28.09, and that one is too small. If you really want to refine it, you can use a calculator to find the actual amount. It's not going to give you a real easy number. It's going to have a decimal point with a lot of numbers after it. So if they in your book, they use an 8-digit calculator, and they come up with 5.3851648. So this number is close to square root 29, but it does not equal the square root of 29 exactly. because when you go to multiply it out, you figure out that the last number starts with a 4, and we would want it to have a 0 there. It was exact. So actually, the square root of 29 is a number that cannot be exactly expressed as a decimal or a fraction, and therefore it is not a rational number. Rather, the square root of 29 is an irrational number. An irrational number. This is a number that cannot be expressed as a ratio of two integers. Cannot be expressed as a ratio of two numbers. Nevertheless, the square root of 29 is a number that has an exact value. For instance, look at the picture on page 695 where you see the triangle there it's a right triangle because it has a little box in the corner. And one leg is 2 centimeters, another leg is 5 centimeters. And we know that a squared plus b squared equals c squared. So 2 squared is 4, plus 5 squared is 25. That 4 and 25 equal 29, and so their answer would be the square root of 29. If we measure the hypotenuse with a centimeter ruler, we find that the length is about 5.4 centimeters, which is approximately the square root of 29 centimeters. Other examples of irrational numbers include pi, the circumference of a circle with a diameter of 1, square root of 2, the length of a diagonal of a square with sides of 1, the square roots of counting numbers that are not perfect squares are also included in that group. The irrational numbers, together with the rational numbers, make up the set of real numbers. So, rational numbers plus irrational numbers equal what we call the set of real numbers. So now we go to example 2 here. You're going to draw a number line and show the approximate location of the points representing the following real numbers. And then describe each number as rational or irrational. Okay, I already drew my number line, so it'd be nice and neat. My first number to look at and evaluate is pi. And as you know, pi equals 3.14. So if I put it on my number line right here, it would be approximately right here. This is pi. And that is an irrational number because it's repeating and it doesn't end. Then we look at the square root of 2. Well, the square root of 2 is somewhere placed between 1 and 2. And so if we place our square root of 2, it'd be right here. It is also an irrational number. Our next number is 2.3 with a repeating sign over the top. And we would place this one in between 2 and 3, but on the low side right here. So this is 2.3 repeating. This is a rational number. It is a rational number. And then our last one is -1/2, which would go right here. It is also a rational number. So this one's rational, this one's rational, this one's irrational, and this one's irrational. Okay, we are ready to start your alphabetics. So get your paper out, get your name on it, be ready. We are now on page 696, and we are looking at the practice set. Starting with letter A, the square root of 7. Now I have to read the instructions. Each square root below is between which two consecutive whole numbers? So, square root of 7. Well, let's see. 1 squared is 1. 2 squared is 4. 2 times 2 is 4. 3 squared is 9. So now we've figured out the bottom and the top. So 2 is the bottom number and 3 is the top number, because 2 squared equals 4 and 3 squared equals 9, and 7 would fall in between those two numbers. Let's look at B, the square root of 70. Now this one might take us a little more time to think about. So let's say 4 squared is 16, 5 squared is 25, excuse me, made a mistake. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. Now we're getting closer. So I would say 8 squared. 8 squared is 64. That's probably the bottom limit. So 9 squared is 81. So this number, the square root of 90, is going to be between the numbers of 8 and 9, somewhere in between those two. Let's look at C, the square root of 700. Okay, this might take us a little longer. 10 squared is 100. 11 squared is 121. 121. 12 squared is 144. We're not even close yet. 15 squared is 225. Let's try 20 squared is 400. That's getting closer. 25 squared is 625. Aha! Now I've got 25 squared. So now we need the upper limit. So let's try 26 squared. 26 times 26. 6 times 6 is 36. 6 times 2 is 12, 13, 14, 15. 2 times 6 is 12. 2 times 2 is 4, plus 1 is 5. And that is 676. Oh, that's not high enough. Well, 25 was wrong then. Okay, so now we have 26 squared. 26 squared as the bottom number. So let's try 27 squared and see what number that's going to be. 7 times 7 is 49. 7 times 2 is 14, plus 4 is 18. 2 times 4 is 14. 2 times 2 is 4, plus 1 is 5. We have 9. 8 and 4 is 12. Carry my 1. 5, 6, 7. 729. So, we will find our number between 26 and 27. Whoops. Yeah, 26 and 27. That's going to be our answer for C. This was our answer for B. This was our answer for A. Now we look at D. D is a drawing. It has a triangle that we're going to draw and identify. There's a 1 and a 1. There's a box showing that this is a right angle. And then we have an X. and they ask us to find the x. So we know by the Pythagorean theorem, a squared plus b squared equals c squared. So this is going to be 1 squared plus 1 squared equals c squared. So 1 plus 1 equals c squared. So 2 equals c squared. And to be able to make it out, I have to take the square root of both sides. So my answer for this is c is going to equal the square root of 2. And that is going to be my solution. C is the square root of 2. Now they want us to find y on this particular one. We again have a right triangle. You can tell because there's a box in the corner. We have a 1 on one side, a y on the other side, and a 2 for the hypotenuse. So we know that a squared plus b squared equals c squared. So we're going to say this is a, so 1 squared plus y squared equals, here's c, 2 squared. So 1 plus y squared equals 4. We are going to subtract the 1 from this side because we want the y to be isolated. And we'll subtract the 1 from this side. And now we have y squared equals 3. And if I take the square root of y and the square root of 3, y is going to equal square root 3. And there is my answer for E. Last one is F. They want you to draw a number line and show the approximate locations of the points represented by the real numbers, and then decide which ones are irrational. And I'm going to leave that one up to you. Draw yourself a number line. Mark the places on it. 1, -1, 0, 1, 2, 3. And you're going to place your answers on that number line. Thank you. That's it for lesson 100. If you have any questions, please call me. My phone number is 831-261-6797. I'll be happy to help you.